All right. So again, last night, hopefully there wasn't too much concern over the homework. Is everybody with me as far as checking your assignment, checking the answers, double checking, verifying? That is absolutely the most important thing you can do. Now remember what I'm telling you. I don't want you just looking at the answers. That's not helping. All right, it's not helping at all. All right. So, does anybody have any questions with last night's? By the way, I did some more research on that as well. So I'm interested to hear for those of you guys who did some research and you have an explanation. I'm going to collect that for extra credit, but not this moment. All right, not at this moment. All right. Does anybody have any questions with the homework?
If boost can fly today equals 5.
That's true. Right? Does it make sense?
Yeah.
It does make sense.
Because 8 equals 5.
All right. All right. Anybody have any questions on the homework? That'd be great if you did not. All right. I'm agreeing. All right. So here we go. Today's assignment is 2-5. All right. And I'm going to start with this. But as you guys are writing down this assignment, I'm going to walk around the room and collect the homework. So here we go. Let me see. If you have the extra credit, you can add it in. All right. Thank you very much.
Can I just write in that choice?
Yeah, you can credit choice. All right, just bring it to me. I'll just sit right in here.
It's due the 22nd.
Thank you.
Yeah.
Is that yours?
Yes.
Turn in your extra credit now if you have it. Make sure you name it homework.
103.
Oh shoot, my is that always right now? Oh shoot.
No, you don't need to write down the entire chart. Okay?
Wait, this one's rolling.
Graph paper. Well, I don't think you should look at it for
Wait, what page is it?
130
All right, do I have the assignments? Yeah. Okay, here we go. Let's try to get this taken care of. Excuse me. Okay, so today we're going to just briefly talk on this, and then we're going to talk about it some more tomorrow. Well, maybe not tomorrow, maybe on Friday or whatever. Again, postulates and axioms you'll hear me discuss a lot, all right? But more importantly, we'll just call it probably a postulate rather than an axiom, but they are the same, all right? And in geometry, the thing that was always the most bizarre to me was the fact that you are proving things from things that you can't prove are true. All right, so you have to accept this as true. Everybody hearing me? You have to accept this as true. How do I know I have to accept it as true? Because that's what it says a postulate is. And these are all postulates. These are things that you have to accept are true in order to move forward in your study of geometry. All right, so again, let's just briefly go through these things. All right, do I expect you to remember that it's 2.1, 2.2, 2.3? No. All right, you just kind of write it out if they ask you. All right, so the first one there, through any 2 points, there is exactly one line. Does that make sense? All right, now, again, I think it's stating the obvious. That's what I used to call it when I was in geometry, stating the obvious. Through any 2 points, there's exactly one line. In other words, you can't say this is a line also through those 2 points. Is everybody with me? All right. So through any 2 points, there's exactly one line. The next one. Through any 3 non-collinear points, there's exactly what? One plane. Now, is there just 3 points on a plane? That's not what it's saying. Are there just 2 points on a line? That's not what they're saying. All right? Through any 3 non-collinear points, that determines a plane. Did everybody get on that? All right. The next thing, 2.3. A line contains at least 2 points. But really, a line contains how many points? Infinite. To me, a description of a line is just a bunch of points right next to each other. You agree with me? But is it possible to define a point? Is it possible to define a line? Is it possible to even define a plane? No. Remember, those are the 3 undefined terms in geometry. Point, line, and plane. Point, line, and plane are the 3 undefined terms in geometry. Yes. Define. Like, define a point. Give me a definition. Give me a definition of what a line is. Give me a definition of what a plane is. It's kind of weird. You can't really do that, right? And I try to tell kids, we can say, well, that looks like a point. Is it round, right? Is it square? Is it big? Is it small? You see what I'm saying, right? We don't know what a point is, all right? Same thing with a line. We don't really know what a line is, all right? We can look at it and say that's what a line looks like, but we don't know what it is. You with me on this? Same thing with the plane. Does a plane have thickness? Right? I don't know. You with me? All right, there's lots of really interesting things about planes that we can talk about later. All right? And 2.4, it says a plane contains at least 3 non-collinear points. Now, why is non-collinear so important?
Because it's on a plane, not a line.
Exactly. If you write, for example, I'm going to erase this so I can show you. Right up here. Look with me, guys. Those are 3 points on a line, right? Does that really define a plane? No. You with me? And I always used to try to tell kids, think of it as like a box, right? If I were to draw a box, and I highlight this part of the box, how many points are on that line? Infinite, right? I mean, there are 2 that are defined if we go here and here. Oh, man. If I talk about that point and I talk about that point. Everybody with me? Come on now, try to listen to what I'm saying. Do you agree that there is another point on that line? Can you tell me what plane I'm talking about, though, if I said, look at those 3 points? What plane am I talking about? Would you have any idea?
No.
No, you would not. There's lots of planes that goes through those, right? There's even one that's on the diagonal there. You see that? It could be the top, it could be the side. There's actually an infinite number of planes that can go through that line. So that's why it doesn't define a line. Everybody with me on that? All right, so the 3 points, as soon as you put 3 non-collinear points down, then you can say, well, that's the plane that we're referring to. Everybody good on that? All right, stay with me now. It's not going to be long today. 2.5. If 2 points lie in a plane, then the entire line containing those points lies in the plane as well. Does that make sense? To me, I like literally, I used to call these common sense. Right? It makes perfectly good sense. Right? But is it possible for me to prove that to you? It's not possible for me to prove that. Does everybody agree? All right. Can anybody possibly give me an explanation of why you can't really prove that? Think of like I'll to give you an example. Listen to me now. Stop writing and listen. Listen. This is called Euclidean geometry. All right. Now, listen. The problem is, think of yourself if you were on like the Earth. All right. Can you walk really in a straight line on Earth? No, because you're kind of walking on a what? You're walking on a ball, correct? So basically what I'm trying to show you, right? So if you continue to walk, it will appear like you're walking in a straight line, correct? But in fact, what? You're not. All right? Just like when you get an airplane and you fly from Tampa to New York. The quickest way would be a line. Do you agree with that? Actually, that's not true. Right? Because we're flying over a ball. Right? Does everybody see that, right? So it's not really, there's no place that's really just flat. Does everybody agree with that? See what I'm saying? So again, if you think of yourself on a ball, right, and moving, it's never straight. All right? So again, that's kind of the things that make it a little strange. All right? And we consider 3 dimensions, correct? And that most people would say space is 3 dimensions, correct? But there are a lot of people that say the actual universe is actually what? Flat. Right? Yes. Believe it or not, we are flat. All right? Doesn't make much sense, right? Until you figure out how big what? How big the universe is. How big space is. The grand scheme of things, all right, we can be like an atom. Very, 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 very small, which is exactly what we are. Technically, very, very small. Right? If you've ever seen any pictures of the universe, right, we are very small. So, in the grand scheme of things, we could be kind of flat. Think of it like your sheet of paper that you're writing on. Right? That seems flat, like a plane, correct? But that piece of paper has width, believe it or not. And that width, there's a lot of things between there. Does that make sense now? All right? Yes. So it appears as if the paper has no width. A long time ago when I was teaching high school, we had to actually measure the width of a sheet of paper. It's not hard to measure the width of a sheet of paper, right? Because you get reams of paper. There's 500 sheets in a ream of paper, right? So you measure the width of the ream and then divide it by 500. And that'll tell you what the width is. All right? So again, it's very fascinating. And for me, one of the things that I could not accept about geometry was we're going to start writing proofs and we're going to start using things that we can't even prove are true. All right? So that's why geometry was pretty fascinating for me.
How
Yes.
wide is the sheet of paper?
Well, I don't remember what it is.
We could find out.
But you could easily go home and take a ream of paper and measure it. I think it was something, I want to say it was like 1.5 inches thick is a ream of paper. So 1.5 inches divided by 500. All right, I think that's about what it was. All right. So again, these things to me were kind of common sense. All right. Now let's just continue knocking this out real quick. 2.6. If 2 lines intersect, they can only intersect at what? At 1 point. You agree with that? All right. And if 2 planes intersect, then their intersection is a what? It creates a line. All right, which I think is pretty obvious as well. All right. Does anybody have any questions with that? So that's the main thing. Yes, ma'am.
The numbers on the side, is that just like the book?
Yeah. So again, that's a very good question. All right. So she's exactly correct. This isn't like a standard. Sorry. This isn't a standard thing. This number right here, if you look up theorem 2.1, it's not going to come up with that. Or postulate 2.1, it's not going to come up with that. All right. Because every geometry book's different. This is just simply saying this is from chapter 2.
Oh, okay.
All right, it's from chapter 2. All right. So again, I'm not going to ask you to write down postulate 2.1 or postulate 2.2. All right. You can kind of abbreviate, and if you want to write 2.1 or refer back to it, that's okay too. But on a test, I'm going to say why is the reasoning, and you're going to say the intersection of 2 points or 2 lines is a what? Point. I'm not going to ask you to memorize that. You're just going to have to be able to state that. Yes.
Could you please go back down to 2.6 and 2.7?
Okay, here we go. There we go. All right, now let's just go ahead and answer some of the questions. All right, let's go ahead and answer some of the questions. No. What I'm going to do is on Friday, I'm going to have this all on a notability note for you. All right, and I'm going to have everything written out for you. because again, I don't really think it's I don't think it's that important to be able to memorize that. I just think you should go, wow, that kind of makes sense. If two lines intersect, it's a point. Two planes intersect, it's a line. I need three non-collinear points to make a plane. I need 2 points to make a line. You should be able to freely say those. All right, it's not that big of a deal. All right, to me, it's common sense. So when you see a question on the test, it's not that I want you to have these memorized. It's that I want you to say, yes, that's obviously true. You with me on this? Everything that is right there in front of you that we just talked about, I would hope that you would just say that's common sense. I already knew that without having somebody tell me that that's true. All right, so now let's get down to the questions here. And then I'll tell you how I want you to do it, because again, I'm not for busy work. Does everybody hear me? I'm not for busy work. All right, so I would prefer that you just pay attention and you just go with me and say, yeah, that's common sense, that's common sense, that's common sense. All right? So here we go. Explain how the figure illustrates that each statement is true, then state the postulate that can be used to show each statement is true. Okay, so for question number 1, it says plane P and Q intersect at line R. So basically that's just saying what? The intersection of two planes is a line. Now look, guys, I see some of you guys are busy bees, and you know how important I think math is and writing all the information down. But do you understand what I'm saying? I'm not asking you to write all that down. That's a waste of time and it's annoying. All right? You have to say in your head, wow, two planes intersect to form a what? Line. I think you should know that intuitively. Right? That's what they're telling you. We don't have to write that down. All right? I want you to just say, obviously, that's true. All right? Now, you might have to look at a figure because they might try to trick you some way, but let's see if they're doing that. All right? So just follow with me. I'd much rather just talk today. I'd much rather just talk. I don't want you writing all this down. It's common sense. All right? Now, some of you just want to write it down. Feel free. All right? Number 2. It says lines R and N intersect at point D. Well, let's find line R and let's find line N. Do they intersect at D?
Yes.
Yes, because the intersection of two lines is a point. All right, let's look at 3. Line N contains C, D, E.
Yes.
That's true. And if you wanted to, you would say a line contains at least what? Contains at least 2 points. All right, so we're good with that. 4. Plane P contains A, F, and D.
It contains at least
That's exactly right. Now remember, everybody has to know what non-collinear means, right? Non-collinear, not on the same line. So do you agree that A, F, and D are not on the same line?
Yes.
Yes, so that's true. All right. Line N lies in plane Q.
Yes.
Yes.
Yeah.
Now, we would say that's true because if 2 points are in the plane, then the line containing those 2 points also lies in the plane.
I thought they had to be non-collinear.
There's no such thing as 2 non-collinear points. You see what I'm saying? If you have 2 points, watch. If you have 2 points, there's a line that goes through them.
Yeah.
Right? Now, you might have been thinking 3 non-collinear, but 3 non-collinears determine a plane. You with me? And listen to me. What she's saying is perfect. Right? It all has to make sense. And if you mistake a term, then that could mess everything up. All right? That's why it's important to listen. All right? Listen carefully. Because, I think this is very easy. And common sense. That's what I used to argue with my teacher all the time. It's common sense. I don't have to write it down.
Yeah.
Right? It's common sense. If you don't know that, right? And you know now common sense. What's the name for common sense, though? What's the name for common sense?
Basic knowledge.
Postulate.
Oh.
Or the other word was
Axiom.
axiom. That's correct. Things that you have to accept as true because we can't prove them. All right? Good.
So being on the edge of a plane like D, C, and E, does that mean they're on the plane?
DC and E is in plane N. I'm sorry, is in plane Q. But is that the only plane that's in? No, it could be on the what also? It could be on the bottom plane, true?
Yeah.
Could be on the side plane. Could be on a diagonal plane also. You know what I mean by a diagonal plane? Like this right here. If I was looking at DC, I could draw this plane right here. Connect that, and now do you see the plane I'm referring to?
Yep.
All right, so just because the plane is not physically drawn doesn't mean it's not in a different plane also. Agree with me what I'm saying? All right, the hardest part is the visual. That's why I'm trying to tell you, stop writing and kind of focus with me so I can show you the visual stuff. All right, I don't remember where we were at now. Are we on 6?
Yes.
All right, line R is the only line through points AD.
True.
I'm agreeing with you,
Yeah.
right? Because it says what? Through 2 points,
One line.
there can only be one line. All right? So big deal. Let's move down. 7, 8, 9. Let's see what they're saying. Determine whether each statement is always true, sometimes true, or never true. Now this is kind of tricky, so try to listen. The intersection of 3 planes is a line.
Sometimes.
I think it can be sometimes, right?
Sometimes.
Right? Because if you're not sure about this, and I always try to visualize a cube. All right, sorry guys. I always try to visualize a cube, right? So now, what I just drew, I'm going to draw again this way. So this plane right here, and this plane, the diagonal plane. Is everybody with me on this now? All right. There's a diagonal plane. There's a bottom plane. Do you agree with this? And there's the front plane, the front wall. They all intersect. Do you agree with me?
Yes, sir.
All right.
Oh.
You see what I'm saying now, right? And I probably should change the color of the one on the bottom. It might help if I change this right here. Then you can see that all 3 of those planes cross over at DE. Does everybody agree?
Yeah.
But if I said the side wall and the bottom wall and the top wall, do they all intersect at a line? No, they don't have to. Everybody good on that?
Yes.
All right. I always think the hardest part on the test is the visual stuff. Okay, line R contains only point P. Obviously, never true. Thank you. Through 2 points, there's exactly one line. Always true. All right, so you guys got it. Let's take a look at number 10. In the figure, that's referring to ray AK is in plane P, and M is on line NE. State the postulate that can be used to show that each statement is true. M, K, and N are coplanar. M, K, and N are coplanar. Ooh, you guys. That is the absolute most common mistake, which is okay to make right now. Tell us, is that true or false?
It's true.
Of course it's true.
Three points are, I mean, M and N are collinear, but K isn't, and those 3 create their own plane.
That's exactly right. He's 100% correct. Now listen to me. Is the plane drawn?
No.
The plane is not drawn. Does everybody see what I'm saying? Just because it's not visually there doesn't mean it doesn't exist. So what's the rule? 3 non-collinear points determine a what?
Plane.
Determine a plane. That's very hard to do, and I'm telling you, you got to listen to me. All right? That's true. 100%. Doesn't matter what points you're talking about. All right? The plane does not have to be drawn, which is why most people make mistakes in the test. Hopefully you're hearing me. I'm going to ask you that same question. And most people say false because the plane's not drawn. I don't care if it's drawn or not. All right? So I'm on 11, right? Line NE contains point NM. What do you think about that?
Yeah, true.
True, because a line contains at least what?
2 points.
2 points, right? So it's possible to have a third point on there. Do you agree? We just didn't name it with what letter? We just didn't name it with letter M. Does everybody agree with me on this? Right? So it contains, every line contains at least 2, so it could have a what? Third point on there. All right? Now, the next one. N, K are collinear. Now, before you say something, hopefully you were listening. If you weren't listening, you're going to say what answer? False. If you were listening, you're going to say the answer is true. 2 points determine a line, period. Doesn't matter if it's drawn or not. 2 points determine a line. Points N, K, and A are coplanar. N, K, and A are coplanar. Do you agree with that? Yes, because all you have to do is determine if they're on the same line. Are they on the same line? Therefore, they make a plane. All right, I'm happy. Is everybody good with that? What's that? So now look here, guys. Do M, N, and E form a plane?
No.
All right, so we argue about this all the time. Is M, N, and E in the same plane?
Yes. Could be. No.
Do they form a plane?
No.
So if they don't form a plane, can they be in the same plane?
Yes. No. Yeah.
No, but I'm saying, if I draw this line, and I don't even, to be honest with you, I can see both points, so I'm not even going to say absolutely, right? Because those 3 points don't determine a plane, then they can't really lie in a plane. You agree with me on this? There is no plane defined, right? Does everybody see my point? But if I draw a plane, for example, I'm going to draw this plane right here. Are those 3 points in that plane? Agreed?
Yes.
Right? Now, if I draw this plane, maybe you can see what I'm talking about. If I draw this plane, how many points are in that plane? Just one of the points. Does everybody agree? Not all 3 are in that plane. Does everybody agree with me now?
Yes.
Right? Could they be? Yes. Do they have to be? No. So what's the answer? I say the answer is never, or not true. And why is that? Because they don't even make a plane. If they don't even make a plane, then they can't be in the same plane. All right? But again, that question is not going to be on the test, so you don't have to worry about it. Because I can see both sides. I think it's next Thursday. Okay?
What are we doing this Thursday?
You know what? I don't know. That'll be tomorrow. Okay?
Well, I've heard
I know. I don't want to talk about it. I want to finish up. Here we go. I don't really care about 14.
right up here.
Okay, here we go. Look at 15 for me for just a quick second. All right, it says in figure at the right, AE is congruent to DB. So we're going to mark that. AE, and you can still pay attention. AE, bad decision. AE would be this. That would be congruent to BD, correct? All right, it's kind of hard to mark it since they overlap.
Right up here. It says we have to.
And C is the midpoint of AE. If C is the midpoint of AE, what's true? Hello?
AC plus CE.
Whoa, wait a minute. Come on, what's the matter, girls?
You said we had to do 1 through 14 and 16.
Oh, thank you. All right, so that's right. I'm going to leave this proof up to next week. All right, because I don't like the way they kind of briefly introduce proofs. So we're going to start on Friday and do all the proofs. Everybody with me? All right, so thank you for that information. All right, so we'll come back. All right. Now, down here, what did I say to do for homework?
16 to 24.
16 through 29
And then 34 through 41.
and 34 through 41. Okay, I think that's pretty reasonable. Now, we have some time, right? When's the bell ring?
27 maybe?
One.
Yeah.
At 27, so we got 12 minutes, right? All right, so let's just go ahead and do some more problems so you don't have to do much
What
for
was the
homework.
other one? 31 through what?
16 through 29.
9.
That's what we're going to do right now in class.
34.
And if you just pay attention to me, you might not have to write this down either.
Yes.
All right, we'll just keep going. Hopefully you can kind of see it's common sense. All right, so here we go. Explain how the picture illustrates that each statement is true, then state the postulate that can be used. All right, so together we're just going to say it. All right, so I'm going to blow it up a little bit here. Lines N and L intersect at point K. So you would just simply say, two lines intersect at a point. Beautiful. Planes P and Q intersect at line M.
Two planes that intersect on a line.
Yes. Is everybody with me, right? All right. Points PD or P, or I'm sorry, points D, K, and H determine a plane. 3 non-collinear points determine a plane. Very good. Point D is also on line N through points CK. What was that one?
Between 2 points, there's a line.
More than 2 points.
There's at least what?
There's at least 2 points.
There's at least 2 points on the line. You with me on this, right?
Yes.
All right. There's at least 2 points on the line. Am I on 20 now? D and H are collinear.
2 points make a line. 2 or more.
Yeah.
Is everybody with me on that? 2
Yep.
points determine the line. Not 2 or more, just what? 2. 21. Points E, F, and G are coplanar.
3 non-collinear points.
3 non-collinear points determine a plane. Good job. Line EF lies in plane Q.
The 2 points are in the line, are in a plane, then the line is a line.
Very nice. Exactly right. If 2 points lie in a plane, then the 2 points that are on the line are also in the plane. Do I agree with that? All right. I'm telling you, it's very easy. Line H and G intersect at point J.
2 lines intersect at a point.
2 lines intersect at a point. All right. Let's just keep going. 24. There's exactly one plane that contains non-collinear points A, B, and C. Sometimes, always, or never. First of all, tell me about the points. How many points are there?
3.
Are they on the same line?
No.
So at 3 non-collinear points
And 1 plane,
always make a plane. True, guys?
Yeah.
Now look, if you're sitting there going, man, I'm not 100%, just let me know. Everybody agree with that?
Yes.
All right, what about 25? There are at least 3 lines through points J and K.
Never, because I forget the rule name.
2 points determine a 1 line, right?
Yes, then you can have more than 1.
All right, what about if points M and N and P lie in plane X, then they are collinear.
Never.
Sometimes.
We can go with sometimes on that
Sometimes.
because it doesn't say that those are the only points in the plane. Do you agree?
Yes.
Oh.
Right? Does that make sense? All right. So we could say sometimes on that. I forgot where we're at.
27.
27. Points X and Y are in plane Z. Any point collinear with XY is in plane Z.
Sometimes.
Points X and Y are in plane Z. Any point collinear with XY is in plane Z.
Sometimes. It can be true, but no.
I thought if the line was in the plane, then all the points that are on the line are also in the plane. Think about what I just said now, because I think it's always, but I want to correct you now what you're thinking now, because most of you didn't say that correctly, right? If you have a line and it's in the plane. It doesn't matter where you put the points in the line, those points are still going to have to be what? In the plane. Does that make sense, right? Doesn't matter. If a line is in a plane, the whole line is in the plane. So it doesn't matter what points you put on the line, it's going to have to be in the plane. Agreed? All right, hopefully that made sense. The intersection of two planes can be a point. False. Never. Two planes that intersect always form a what? And how many points are on a line? At least two. So that's definitely never. Points A, B, and C determine a plane. Very good. If they are non-collinear. Thank you. All right, very good. So I told you guys, I'm pretty happy with today. And I want to see if those are the rest. Is that the rest?
Yes. 30, 40, 41.
I know, but I'm trying to see if those are the same. It's the same. Do you agree?
Yeah.
All right, I'm pretty good. All right. So again, that is it. No homework tonight. How's that? All right, no homework.
So we don't know.
All right, you don't have to do anything more. I just read them real quick, and it's kind of easy. Right? It's the same information. Now, if you're sitting here not sure, right, I promise you, if you read those statements over several times, Walker, what are you doing?
Doing orange justice.
Orange justice. All right. Thank you for the dance. All right. I can't unsee that. I want you to know. Okay. Here we go. So read through those. That's the only thing I'd ask you to do. All right. You are welcome.